Hello and welcome back to the third video in the series for topic 3 networks, and this time we're going to be defining the terms protocol and data packets. This is for the IB Diploma in Computer Science. Okay, you can see here we've got the 4 core topics and we're on the third one, networks. And we've just finished network fundamentals, we're just about to start data transmission. So, objectives. Define the term protocol and explain its importance in networking. Define the term data packet and break this down into its component parts. Understand how protocols and data packets work together to enable data communication over networks. Okay, so first of all, what is a protocol? Well, a protocol is a set of rules for data communication, this being over a network. So the key points we're looking for: protocols define the format and order of messages exchanged between two or more communicating entities. They dictate the actions taken on transmission and or receipt of a message. Okay, so why are they important? Well, protocols ensure that the devices from different manufacturers, different hardware, can communicate with each other. They standardize communication, making it possible for devices on different networks to understand each other. For example, we are using a protocol here, Hypertext Transfer Protocol, HTTP. You may have seen this, or HTTPS, Secure Hypertext Transfer Protocol, and it's used for transferring web pages over the internet. Basically what appears on your browser, okay, when you send a request to the internet for a particular website. So it's basically used for transferring web pages over the internet. It defines how messages are formatted and transmitted, and how web servers and browsers should respond to various commands. Basically, we've sent something www.netflix.com. This sends it to the web server to get the IP address. The IP address comes back across the internet, and then that's registered on your web browser as being the Netflix website, and up it pops. Okay, so that's basically protocols, and we will go into a lot more detail on this. And then we've got data packets. So a data packet, what is a data packet? This is sort of an obscure, abstract version of data packets. A data packet is a small unit of data used in network communication. Data packets carry data over networks in manageable pieces. They include information for routing and error checking. Okay, somebody wants to email a great big file to somewhere else on a network, somewhere else in the world. A great big file, a massive video file or a massive block of text. So what generally happens is, rather than sending this all in one go and it's slowing the network down, and it's maybe it gets there, maybe it doesn't, depending on the speed of the network, what we're going to do when we're sending this data over long distances, we're going to break it up into small parts known as what are called data packets, as you can see here. The packets of data are usually quite small, typically about 64 kilobytes, which are much easier to control than a long continuous stream of data. Okay, the idea of splitting up data in this way means each packet can be sent along different routes to its destination. So with routers controlling where each packet is going to go, it should speed up the process. This would clearly be a great benefit if a particular transmission route was out of action or very busy. The only obvious drawback of splitting data into packets is it needs to be reassembled once it gets to the recipient, once it reaches its destination. Okay, so for example, here is a recipient, he's got data 1, data 3, and data 4, but where's data 2? How this works? Well, we've talked about protocols being a set of rules for data communication over the network, but they're also a protocol defines the format and the order of messages exchanged between two or more communicating entities, as well as the actions taken on the transmission and or the receipt of the message or other event. Okay, so it's governing how these work, how these are sent, how these are received, how they've been split up, and how they've been put back together. So let's have a little look at this. A data packet can be broken up into 3 parts: the header, the payload, and the trailer. Okay, so a little bit like a lorry. Okay, you've got the header where the driver sits, and in that we've got the IP address where it's coming from. Okay, where it needs to be picked up from, the receiver where it's going to go to, the sequence number of the packet. Okay, before it gets reassembled, and the size of the packet, how big is the amount of data in that particular packet. Okay, so that's the header. Then the payload is basically the information, the data. Okay, usually, as I say, around about 64 kilobytes. And then the trailer, the final bit, yeah, the bit where the payload sort of sits on, if we think about it like a little lorry, like a little truck. The trailer is the method of identifying the end of the packet. Okay, so if we know where the end of packet 1 is, then we can put 2 and join 2 onto it, then join 3 onto that one, then join 4 onto the next one. Okay, there is also some form of error checking to ensure packets arrive error-free. What we need to know is when each packet has been split up, that data is the same data as what's been received by the recipient. Here's an example, somebody with a bag on the head. This is representing the header. Okay, for each packet, the packet header consists of the IP address of the sending device, the IP address of the receiving device, the sequence number of the packet, and the packet size. Also, it may contain other values indicating how many packets there were in total for that particular transmission. Okay, so, as I said, IP address of the sender, of the receiver. So the sequence number, this is to ensure that all the packets can be reassembled into the correct order once they reach their destination. Okay, and then finally, the size of the packet. This is to ensure the receiving station can check if all the packets have arrived intact. So the payload is basically the contents, the information, the data, a little bit like you've got your handbag here with all your stuff inside it. Okay, this is what the payload is. Basically, all the information that has been put into that particular packet. It's not a real packet. It's just a bunch of zeros and ones that have been sort of grouped together and taken from part of the sort of the big picture, the big data. So, as I said before, usually about 64 kilobytes. Okay, and then finally, we've got the trailer. Again, for each packet, the trailer consists of, again, some way of identifying the end of the packet. This is essential to allow each packet to be separated from each other as they travel between nodes, and then finally at the end when they're received by the receiver's station. And error checking is usually put in place as well. And I'm going to talk a little bit about cyclic redundancy checks or CRC checks. Okay, so this is one of the most common ones. And what this is, it basically involves the sending computer adding up all the 1 bits of the payload and storing this as sort of an hexadecimal value in the trailer before it gets sent. Once the packets arrive, the receiving computer recalculates the number of 1 bits, the bits that are identified as 1 in the payload. The computer then checks this value against the 1 sent in the trailer. If the 2 values match, then no transmission error has been occurred, otherwise the packet needs to be resent. Okay, so that's one form of error checking at the end, cyclic redundancy checks, CRCs. Okay, so in conclusion, the protocol is a set of rules governing data communication. The data packet, is a small unit of data used in network communication. Now together, how these work, protocols and data packets enable reliable and standardized communication between devices on the network. Again, as always, a set of questions. We've got question 1, define the term protocol as used in computer networking, 2 marks. 2, a little bit more detail please, describe the components of a data packet, 4 marks. And question 3, explain how protocols and data packets work together to facilitate communication in a network, 6 marks. Okay, if you don't want to see the answers, pause the video, but I'm going to move on. Question 1, a protocol is a set of rules or standards that define the format and the order of messages exchanged between 2 or more communicating entities in a network. It also specifies the actions that should be taken on the transmission and or receipt of a message or event. We're breaking it down into the header, and what's in the header, the IP address of the receiver, the sender, okay, the sequence number, and the specific packet size. We've got the payload, which is basically the data, usually 64 kilobytes, and the trailer, which contains the error checking, and it contains where the packet ends, so it can be joined onto the next consecutive packet. 2, a little bit more detail. Protocols establish the rules for how data should be formatted, transmitted, and received across a network. They ensure that different devices, even from various manufacturers, can understand and communicate with each other effectively. Data packets are the small units in which data is broken down for transmission. These packets are sent individually across the network and may take different paths to reach the destination. Protocols govern how these packets are assembled, transmitted, and reassembled at the receiving end. And for example, we've got HTTP, which we talked about earlier. The protocol specifies how a web page request is formatted and how the server should respond. The web page data is then broken down into packets, each containing a portion of the data. These packets are sent to the client where they are reassembled into a full web page. The protocol ensures that the packets are sent in the correct order and that any errors are detected and corrected, ensuring reliable communication. Okay, that is it for this video. Thank you very much indeed for watching, and I will see you next time. Bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.